Toby Blunt is a partner with Norman Foster and Partners from the London office, and he's here to talk about the Index in Dubai, which is the winner of the 2011 Best Tall Building in Middle East and Africa. Congratulations on the award and on a very distinctive building.
Thank you very much, Jeff. It's an honor.
The questions that we're asking everyone this year is kind of our experts panel. We'll start with those. The world's next tallest building, the Kingdom Center, or the Kingdom Tower in Jeddah, Saudi Arabia, 1 kilometer high, more than a kilometer high. And now you work with super tall buildings. What is the single biggest limiting factor that limits the height of tall buildings?
I think it's a very good question. I mean, we, interestingly enough, back in the 90s, we actually did some work, almost a theoretical project, on how you build a kilometer-high tower. We actually had a site for it, but unfortunately it didn't actually go ahead. But at the time, one of the biggest limiting factors was actually how you move people vertically up through the building, and lift technology. And so one of the things we were actually pioneering at the time was working with lift manufacturers, was how do you overcome the traditional sort of traction-driven lifts and get into electromagnetic lifting, and lifts not necessarily moving just vertically but also horizontally, because one of the things about moving up through a tower is getting people to where they need to go very, very quickly. That's certainly one of the big technical aspects of thinking about when you design tall towers.
And I remember the project, it was the Tokyo Tower project,
right, yeah.
Which we were all fascinated looking at the time because it was 2,700 feet tall.
That's right.
Now we have a building in the world that's 2,700 feet tall.
Yeah.
The similarities and differences between the Tokyo Tower and the Burj Dubai, or the Burj Khalifa, what do you think of when you see these? Think of these two buildings.
Yeah, I mean, I think there are similarities. I mean, I haven't actually had a chance to go into the Burj Khalifa yet, so I'm not sure. I don't know whether they've resolved some of those issues about how you move people around. But I mean, socially, there are issues about, you know, how it's a mixed-use building. How do you encourage people to go and live in that type of environment? Sustainability is also an issue of how the buildings respond to the energy usage and consumption. And these were things we all pioneered or looked at, certainly when we were looking at the Tokyo Tower.
The next question about tall buildings, can they ever truly become carbon neutral?
Yeah.
Is that possible?
I think we believe it is. But we believe you've got to look at tall buildings not in isolation. You've got to look at them, how they integrate with the urban, you know, the cities. Tall towers are generally efficient building forms within a city, within an urban grain. And so we think not only as you can look at the building, and then as technology develops and concepts develop about how you use energy, how you recycle energy, and all those sorts of things, are simple things you can think about in a tower. But there are other things socially about how towers sit into a city and how it helps reducing transportation issues. Mixed-use towers are very important. You know, and all those things. People talk about embodied energy in materials. There's a whole series of work and studies done looking at how you think about the types of materials that you actually use in the construction. And, you know, engineers have you know, broken the mold, as it were, in terms of their thinking for creating structural systems that allow efficiency, and efficiency has a knock-on effect to material use and recycling. For example, recycled steel, which we've done buildings. Certainly the Hearst Tower in New York, 90% of the steel frame for that building was actually made from recycled steel. So we believe there's a lot of work still to be done. It's certainly not there at the moment, but we believe it can be done, and as we continue to develop ideas, it can be done. But also, it needs support from governments at legislation level as well. To ensure that owners of buildings and operators of buildings actually meet those criteria as well.
I know Foster and Partners is one firm in the world that is very, very much plugged into the issue of sustainability.
Yeah.
How much analysis and what kind of analysis you do of a cityscape when you design a building for it? Because the way that I think, at least of tall buildings, you kind of hook them into the existing infrastructure. It's kind of like a circuit board, and you're plugging in a component. How do you look at that, and what kind of analysis do you do?
Well, we do an awful lot of analysis. I mean, within the practice, we actually have our own research group, which we've built up over the years, and primarily to take on board a lot of that thinking. And a lot of that work that goes on into how cities operate, how cities work, how the infrastructure of cities The Masdar project, the master plan, the sustainable master plan project that we pioneered in Abu Dhabi, took a lot of those ideas about how cities work and operate, and we wanted to portray a sort of model of a modern city and a sustainable city. So there's a lot of thinking that goes into that, and a lot of work and effort that goes into that. So we don't simply just plug a tower into a city. You do have to think about the existing infrastructure, and sometimes you can't change it. Sometimes it's already there. But you can, in terms of things like CHP, control combined heating and power systems, if you've got enough, enough people, enough mass, if you've got different functions in a building, so for example, you've got a residential and office. Residential buildings are occupied at different times of the day from office buildings, so you can think about the energy use of the building and how you share that energy through the tower.
It has been 10 years since 9/11. How are buildings, how terror-proof are buildings now? What have we learned in the last 10 years? What's changed?
Yeah, I mean, I think your question was, I think originally was how safe buildings are from terrorism. Obviously terrorism, no one can ever be truly safe, I don't think. Terrorism is looked at from a much broader scale at government level. When it comes down to the actual building, I think architects and engineers have made enormous leaps in thinking about how buildings perform under a particular effect or action or impact or something. And a lot of lessons were learnt from what happened on 9/11 in terms of evacuating buildings, in terms of progressive collapse, the structural systems, all those things. And we actually did some work after that of our own research work, just looking at how you would address that very question about how do you make tall buildings safe under such a similar sort of attack. And there were some interesting ideas that came out of that, some of which are sort of embodied in design, I think, now just generally, and other ideas which were sort of slightly more out there, which may in the future come into fruition.
Was these kind of design changes, were these things that were going to happen anyway, or was 9/11 a real impetus for those?
Probably they would have happened, but I think certainly there was an impetus there, because I think everybody in the world was taking note, and clients around the world, when they're commissioning buildings, tall buildings, and that was a time, that building is an older building. Things had moved on already in terms of the design of super tall towers, but clients looking to build these things had concerns about were their engineers, were their architects actually addressing the issues that had come out of that event.
Here's a question that we love to ask everyone, and you have to leave Foster and Partners out of this, is what do you think is the best tall building in existence today, and why?
It's a very good question, and actually, interesting enough, for me, it's actually the John Hancock Tower, or Center here in Chicago, because for me, when we were designing the index building, we spent a little bit of time looking at that building and sort of understanding it. And the work that Khan did on the engineering side was actually very interesting in terms of redefining a sort of structural system that allowed people to build towers much taller than they had been able to, and also making them much more efficient. So, the steel structural system makes a very efficient tower, and makes it a very flexible tower, and therefore it makes it to a certain extent sustainable. And it was also one of the first mixed-use towers as well. So again, that was pioneering work and a breakthrough in terms of not only engineering but also socially, and how people actually started to live in tall towers. So for me, it was a very interesting building, and aesthetically, I think it's pleasing for me because it expresses the structural systems that actually hold the building up.
Well, we're here to talk about the index, which is the best tall building winner in the Middle East and Africa for 2011. And that's the first thing that struck me as I started to look over the stats for this building, is the height is almost identical to the John Hancock Center. And like the John Hancock Center, it's a mixed-use building. And kind of like the John Hancock Center, the first thing that gets your attention about the index is the slender profile. Even more so because the end-on view is so slender. Tell me what the client was looking for here, because you said that you were in on the design of this building from the very beginning. What were you presented with, and what did you actually end up with?
What we were presented with, we were presented with a site that was contained within what they call the International Finance Centre, the Dubai International Finance Centre. So therefore, the client was looking for a building that would meet the function of the sorts of companies that would go into a financial centre, primarily banking or financial institutions. So one of the early things we wanted to do was think about a flexible floor plate, commercial office floor plate, flexible floor plate. They didn't have a tenant at the time, but at least they'd narrowed down the end user to a type of end user, so we could understand what their needs would be. So one of the first things to do was thinking about the commercial office floor plate and how we could make that as flexible as possible. They did want a mixed-use building. There was a lot of value in providing residential accommodation within that. It was effectively a free zone within the city of Dubai. So there was quite a lot of premium for the client to have residential in the building. The original master plan was actually 2 towers. It was 1 residential tower, one commercial office tower. The other ambition the client had was to meet a height aspiration. They wanted to create a building that was tall. The Emirates towers were at the time the tallest towers in Dubai until the Burj Khalifa came along. And politically, they didn't want to go any higher than I think the tallest of the Emirates towers is 350. They didn't want to go any higher than that. So we had a challenge to get the mixed use working and also to meet a height aspiration as well.
And it's interesting you said that this building was originally 2 towers, because so was the John Hancock Center.
Right, that's right.
Were there that many strong similarities between the 2 projects, and what did you learn from the John Hancock Center?
Well, the interesting bit about the index, and I think you can see it in its structural form, was a very close collaboration between us and Bob Halverson from Halverson & Partners, who is actually from Chicago. And we had workshops here with him in Chicago, and he was at the time looking at structural solutions for a tower of that sort of size. And obviously the John Hancock, the Sears Tower, there's great examples here in Chicago of towers of that height. So we spent a little bit of time with Bob looking at those designs and those systems and trying to analyze what was the right structural solution to go with, along with the client and the client's needs in terms of financial budgetary constraints about whether we should use a steel frame solution, whether we should use a concrete solution. And all those things sort of came together with yes, we learned a lot from looking at the Hancock Tower, but ultimately we went away from certainly the structural solution that the John Hancock used.
I think the thing that's interesting about this is the structural system that you did come up with is really about a lot of the support on the sides as opposed to a core. Could you explain a little bit about that? Because the building looks so thin,
right,
it's almost like you can see through it from one end to another, yes, being on a floor, which is very unusual.
Yeah, I mean, a lot of it came out of thinking about the drivers. What is the driver? And the floor plate was one of the drivers. And actually, we wanted to get sort of a wide floor plate, clear span floor plate. The idea of pushing the cores away from the centre of the building was also something that we did quite early on. We'd done some work on our tower in Sydney where we'd moved the core away from the floor plate, and we got very efficient floor plate configuration. So we were looking at how we do that, pulling the cores away from the centre, freeing up as much of the floor plate as possible. The other thing we were looking at in terms of sustainability was the depth of the floor plate and how much natural light you can get into a floor plate. We didn't want to have your typical sort of, if you like, square rectangular floor plate with a core in the centre, very deep floors. So we wanted to try and narrow those as much as we possibly could. So it was a combination of all those things that ultimately came up with the sort of form that we're talking about. There wasn't a particular driver to try and get it narrower and tall. It was more a function of the way in which the diagram for the design of the building came about. But ultimately, the height to the sort of what do you call it? The narrowness of the building is actually quite extreme, and that adds to the elegance of the design. But as you say, as you turn it around the other way, it's actually quite a wide and flat building. But we also use that profile in other ways in terms of the orientation of the building, how we've used the wind hitting the building. So the form and the shape of it has helped in all sorts of aspects.
It looks like you had a lot of opportunities to do interesting things with floor spaces inside just because you weren't dealing with a box.
That's right.
And as you look at pictures of some of the interiors in there, you get some wonderful angles, some wonderful corners and interior spaces that don't look like you're in a box-shaped room.
Right, yeah.
What kind of floor plates or what kind of plans did you explore with the way those were configured?
Well, on the office floor, we were primarily just trying to get a system where we could get a column-free space. That was one of the priorities that we had. The residential building, which effectively is a completely different model, you don't need column-free space. In fact, you find that residential has a number of, obviously, walls dividing apartments and walls within apartments. So the solution was really to go for a residential building that was concrete, that had shear walls running through it, and effectively resting that building on a huge beam that sits at the mid-level of the building, which we've expressed. You can see where we've expressed that, with the gap between the residential and the office building. So effectively, the whole weight of the residential building gets transferred out through this large beam structure out into the edges and into the A-frames that support the rest of the building. And what that meant was we didn't have to bring any of that structure. Normally in a mixed use, you have to think about structure and services as well, coming down from a residential building and passing through an office. So what we were able to do at that transfer level is take all the services and structure and actually move those to the one side and drop those down the cores that run down the outside of the building, thus freeing up the office floor and giving us as much flexibility as we wanted to in there. Of course, the only thing you do have to have coming through the middle, unfortunately, of course, is the lift core, which you need to take people up to the residential. So there is a core within the centre of the building, but it's just a very high-speed lift that takes you up to the sky lobby.
The financial model of this building, you do have penthouse levels.
That's right,
at the top.
Yeah.
Tell me about the design of those and what did that do for the financial aspect of the whole building that the client liked?
It was always, I think, residential. There's always, when you're in a tower, there's always a premium, as you say, for putting higher quality penthouse apartments on the very top. Tops of buildings are always difficult to, especially towers, are quite difficult to think about. And we went through discussions about whether we should add, radio masts or something on top of the building. But ultimately, we felt that what was interesting about the structural system was actually the structural system, by the time it got up to the top of the tower, is actually no longer needed in many ways because it had done its work. So we could actually stop the primary structural system, and the penthouses were able to sort of crown the top of the building and create quite an interesting top to the tower and finishing off the tower. And that obviously added not only visual interest, but also added the opportunity for an owner to have something very special that sits on top of the tower that could be identified. And we were able to make those larger floor-to-ceiling heights, get big spaces in there, external spaces. We even have swimming pools up on those penthouse levels. So they're very exclusive apartments. One
thing that we didn't talk about very much when the John Hancock went up was the way that the building met the street.
Yeah.
And looking at the photos of the index, I was really struck by kind of what an intimate, enclosed area you've got at the bottom of the building. It really is almost an environment by itself. Yeah. Tell me about the design of the bottom and what you were aiming for there, what you've achieved.
I think whenever we think about towers and we think about cities, we also think about the public realm. And it's very important for us to think about the way in which a large building comes down and meets the ground floor and how it interacts with people, because it's very important not to alienate people from these large structures. So it was very important for us to think about, as you say, making a welcoming space at entrance area at the bottom of the building that wasn't intimidating but also had some feeling of grandeur and a great space. The building sits within a master plan that ultimately will get built out and it will become more integrated into a city. At the moment it sits slightly isolated. But the idea was really to create, we didn't want to actually enclose the underneath of the building in the traditional sort of lobby space. We wanted to actually open that up as much as possible. And we also brought in a water feature which is actually about 200 meters long, which wraps all the way around the edge of the building as it comes down to the ground. And we run water over that constantly. And what that actually does, because it's open air and there are water pools, and it's shaded because there are canopies which protect that space, what actually happens is you provide actually quite a cooled, shaded space in the outside in a very harsh environment like in Dubai. And you get some of the effect of evaporative cooling from the water, and also air movement that hits the tower and comes through. So all those things actually help us reduce the temperature of the environment at that level, although it's an outside space. And you know, I think everybody who goes there is quite enamored by that, the feel of the space. And then we created more enclosed spaces as you move into the office lobbies and the residential lobby. So it was done really as a response to a pedestrian and people level, and also to try and create an environmentally controlled space, but not do it through mechanical means, do it through passive means.
Because when you think of how big this building is, it's a very large building, and of the index, the council jury said that the building takes a particularly interesting approach at its base, with only its structural fins and cores coming all the way to the ground, so you have a lot of open space, while the rest of the space opens up in an open-air shaded atrium with large pools that create a cool microclimate around the tower's entrances. And this is a stark contrast to the fully enclosed glazed lobby spaces typical of most tall buildings. It feels so intimate, it feels so welcoming. And I think that's what struck me about the photos at first.
Yeah, yeah.
The social dynamic in the John Hancock Center really kind of defined Chicago, because it was such a tall building that redefined the city skyline and the way that we think of height. And there was a whole new social dynamic going on there, in that you had a building that people could not only live in but work in. What's the social dynamic of the index?
I think it's the same. I think the idea was that you can live in the building and you can work in the building. It actually also plugs into the master plan, which has a large retail area at the lower level. And actually, if you walk through our lobby space and you actually walk through the water wall at the back, you actually go into a retail space, which is then ultimately connected into the large mall. So the idea being that yes, you can live, work within that space. You can go and you can get the retail as well, and hopefully that helps people to stop using the car. There is parking, obviously, but hopefully people can leave the car and they can still use a large part of that. The master plan, the DIFC master plan, they can walk around, they can use spaces, different activities, and as you say, they can live and work there. So sustainably, sociably, it is a model that I think is the way to go with when we think about these types of buildings in the cities today.
I'm going to backtrack a little bit and ask you to talk about the evolution of the form of the building, and how, just because it's so unusual, how you started out and what the process was that led you to what you ended up with.
Right. Okay. I think one of the big decisions was, if you like, was the sort of diagram about how you move people up through the building. I remember we had a large piece of paper on the wall, and we were sort of sketching these ideas about, putting a residential building on top of an office building. How do you get people up into that space? How do you move people around the building? How do you service the building? So it came very much from a sort of diagram, an efficient diagram of movement, vertical movement through the building. That was one of the things we did. And almost then with Bob Halverson, we sort of talked about how he would think about holding that building up, what sort of structural system he would use. And the idea of these large sort of concrete columns that come down, that sort of come in the east-west direction and on the north-south direction. They create this sort of A-frame that's inherently stable. It's wider at the bottom than it is at the top. So they come down and they get wider. So it inherently has that kind of stability system to it. And then we use the cores, structurally use the cores to stop the twist and the shear forces and overcome all the sort of seismic forces that were necessary. So it came out of a really close collaboration about architecturally how we wanted to see the building, and structurally how it was going to stand up. And And you know, once we had the idea that we were using these large structural columns, if you like, or A-frames, architecturally we didn't want to hide them. We wanted to express them and actually pull them out and make sure that people looking at the building, as you say, really understand what it is that's holding the building up, and you can really see the structure that's holding it up and really understand how the building, you know, how it exists. So I think it's a combination of thinking about how a building comes together in its different components, the structural systems that then we decided to use, and then how we architecturally treated those systems. You know, and how we thought about what we wanted to do. We almost wanted to express the concrete as pure concrete. You know, we would have been happy if you could construct concrete in a way that it was very elegant and clean and was unclad. Obviously, technical difficulties in terms of construction techniques did enable us to do that. But so we did actually ultimately clad those concrete columns, but we clad them with precast concrete panels, where we've added some ripple effect into the form of those. So there's a sort of slight shadowing effect that goes onto each of the panels. Just adds a little bit of interest to those fins. And on the other interesting bit is on the south facade, because the building is orientated east-west, and that was a conscious decision to twist the building and push the cores so that the cores on either side of the building are directly east and west, thereby shading the sides of the building so you don't actually get direct sunlight into the floor plate. The north facade obviously doesn't need any shading devices, and the south facade we've actually added shading elements, and they become part of the architecture of the building as well. So it's things like that that the building really sort of came out of the thinking. I think that's really
yes, and the other comment I was going to make was the building kind of looks like a radiator of sorts, because you are dealing with an awful lot of solar radiation coming in there.
That's right.
And you have to reflect, I suppose.
Yeah.
How did that come out in the cladding? How does the cladding accommodate that?
The concrete. The idea with the concrete, there's an inherent thermal mass in the concrete panel. So we did. You know, you can reduce some of the sort of heat load onto the building from that. The shading elements really are the key to protecting the facade. We used performance glazing systems, but on the south, the shading elements were the key to that. And then on the fins that actually come out, actually self-shade the facade to a certain extent as well. And if you look at the residential building, it's quite in and out. And so we use those sort of recesses as ways to self-shade the next bay. And we also introduced balconies. Some of them have actually got balcony spaces as well. And the other interesting thing we did is on the residential, we actually allowed, rather than opening windows, which is kind of unheard of in that part of the world, we actually allowed these small vents either side of the bays as they come out. There's small vents which are actually openable by the owner, and you can actually open the vents and allow cross ventilation to occur into the floor plan, which again is something quite unique for a society there that generally relies on air conditioning 100% of the year. Because actually in the winter months it's actually reasonably it's a reasonable temperature, and you can actually open and allow airflow into a building.
I'm trying to imagine, again, the differences between the Hancock and the Index and the technology then versus now, and what some of the structural differences might be. And I'll let you describe how the technology has changed between the two buildings, but it almost sounds like with the system that you had, that you were able to kind of pick and choose the elements that you wanted to include it within this frame. Yeah. And put them where you wanted, this bank of floors. Yeah. Is that correct?
Yeah, I think so. Yeah, I mean, the Hancock is obviously a different structural system to achieve the ends. The use of steel in that part of the world, in Dubai, isn't necessary. I mean, yes, the Burj Khalifa is a mixed, it's a composite system, steel and concrete. We use steel in the building. I mean, the floor spans on the office floors are 24-meter clear span steel trusses. So we do use a combination. It is a combination of steel and concrete, but it is a different structural system from the Hancock Center. I don't know if that answers your.
Yeah, the technology question. Is much different, and obviously
the technology is different, but it's yeah, it's a different technology. It's a different type of construction. Massive concrete walls, huge amounts of reinforcement in the walls. getting very, very rigid forms, very stable. I mean, the tower is not intended to move. There's no real great movement in it. There's no need for any counteraction or anything like that in the tower.
Well, I want to thank you for dropping by, and the index in Dubai is the winner of the best tall building in the Middle East and Africa for 2011, and Toby Blunt from Foster & Partners. Thank you.
Thank you very much.